Hello everyone, welcome to Engineering Open House 2021. My name is Dongchen Wang from Hydro System Lab at Department of Civil Engineering, and now I'm going to present you the hydraulic rocket. First, I'd like to thank my dear friends and colleagues Ari and Afifa for their help recording this video, and I'm also like to thank the EOH committee for their organizing the whole event. This video is not to teach you how to build a hydraulic rocket, but to talk about the science behind it. The same science behind the real rocket.
8, 7, 6, 5, 4, engine ignition, 2, 1, 0. And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
First, I'd like to introduce you some basic concepts. The first concept, velocity. The velocity describes the speed of an object. The higher the speed is, the higher the velocity is. Such as cars and the rockets, they're moving at a really high speed and they have very high velocity. The second concept I'd like to introduce is the pressure. The pressure describes the force acting on a unit area. Imagine you are pressing a balloon. The larger force you're using, the higher pressure inside the balloon is. The third concept I'd like to introduce is the Bernoulli principles. Bernoulli principle is an energy balance that connects the pressure and the velocity. The same principle can be used in the rocket, the airplane, and also our project hydraulic rocket. If in the future you go to the college, you come to our hydro lab, the professor will teach you the actual details inside the Bernoulli principle. Although it sounds complicated, it has a simplified form like this. The left side of the equation is the velocity squared, and the right side of the equation is the pressure divided by density. From this formula, we can see that if we have the higher pressure on the right side, it will lead to the higher velocity on the left side. Now, I'm going to demonstrate how the Bernoulli principle works using our hydraulic rocket, the plastic bottles. Remember to recycle them after using it. This is the figure demonstrates what is happening inside a hydraulic rocket. There's water on the bottom of the bottle and air on top of the bottle. If we keep pumping air into the bottle, the pressure of the air will increase. It's like if you keep eating, you feel full. If you keep eating more, you feel pressure on your stomach. It's exactly the same idea. When we pump enough air into the bottle, we can launch the rocket. At that moment, the static energy of the air pressure will transform into the velocity of the water. Then the water will pushes the bottle or the hydraulic rocket to the sky. This is the launch process. So now here's the question. If we have two hydraulic rockets, one filled full bottle of water, the second one filled with only half bottle of water. If we put the same amount of air pressure inside the hydraulic rocket, which one flies faster? take a moment to think about your answer. Ari and Afifa will launch the real hydraulic rocket. Let's find it out.
Hi, my name's Ari, and today we're going to learn how to shoot off a hydraulic rocket. As Dongchen just explained to you, we have one bottle halfway filled with water and another full filled with water. Which one do you think is going to fly farther? We're going to start with a half bottle.
Some people will think the rocket with more water will fly faster. But according to our Bernoulli's principle, if we have the same amount of pressure, it will have only the same amount of velocity. So I will say that two rockets with the same pressure, different amount of water will fly exact the same velocity. Thank you.